For this example, I'm going to show you two ways of doing this. We're going to use identities, the negative angle identities, or we can also use reflection. Okay, so the first way I'm going to show you is making use of the identities. We have the negative angle identity for sine, which says that the sine of negative x is the same thing as the negative sine of x. So when I write my function here, y is equal to sine of negative x plus 3. I know there's a vertical shift. This plus 3 tells me I have to move my function up 3 units. I will rewrite this, and instead of writing sine of negative x, I'm going to write what this is. It's negative sine of x according to my identity rule, plus 3. Okay? And now this is my sine function reflected across the x-axis and then moving up 3 units. So let's draw my sine function here. Sine always starts at 0. And there are my 4 intervals, 1, 2, 3, 4 intervals. So I'm just going to draw sine, and then I'm going to reflect it. And then I will move it up 3. So here we go. Let's say this is 1, and this is negative 1. So I come up, I get my maximum value, come down, reach my negative. There it is. There's your sine cycle, and you can continue. 1, 2, 3, 4. And there you have it, and then you can do the same thing on this side. You get the idea. Okay, that's my normal sine function. This negative outside says reflect the function across the x-axis. That means, let me change colors. That means that I'll start at 0, and whatever's on above the x-axis is now below the x-axis. And there's your reflection across the x-axis. Okay, beautiful. So your pink function so far is this part. Plus 3 is taking that pink function, taking your x-axis, and bringing it up 3 units. So if this is 1, this would be 2, and this would be 3. So I'm going to transport my x-axis all the way up here. Okay? And I take my reflected graph. Let me draw my interval so that it's neater. And I'm going to change colors. And we said that we go under, above, and this is 1 unit, right? 1 unit. And so forth. And then on this side, let me draw my intervals. There it is. This should match the pink one. Except that the pink one, I stopped here. Okay, there it is. So your purple graph is your final graph. Now, if I want to do this differently, this is what you would do. Y is equal to the sine of negative x plus 3. This negative inside the function is a reflection, but instead of a reflection across the x-axis, it's across the y-axis. Okay? So let me get a new coordinate plane here. And there we go. Okay? So I would go ahead and draw my sine function. Let me draw my intervals so that it's neat. I would draw my sine function. Let's say this is 1 and -1. Like so. And I can repeat it there. 2 cycles. And since I have a negative here, that means reflect this across this side. So that means if I fold across the y-axis, if I fold this paper across the y-axis, I would have, let me draw my intervals, it would look like this. There's 1 cycle. And there's 2 cycles. And there you have it. Okay? And I can keep going, right? I can continue on this side. And notice how I've created the same curve that I created in the previous example, where anything that was above the x-axis is now below the x-axis. So a reflection across the x-axis and a reflection across the y-axis for the cosine function looks identical. Okay? And let's see that in GeoGebra. Oh, I had to bring it up 3 after this, right? So 1, I forgot about that, I'm sorry. Here's 3. This is where you bring your x-axis to. And then you draw your graph. Okay? And you get the idea. Let me show you in GeoGebra. Here it is. Sine of -x plus 3. Here's 3. We have the graph underneath and then up. Same thing here. So we get the same graph if we reflect across the y-axis or across the x-axis for this function. I hope this example helps you. I will see you later.